Today, we're going to be checking out the future of WebXR. Now, XR is a new term. It's one of those terms where there's no real agreement about what it actually means. But for the purposes of this talk, virtual reality, augmented reality, mixed reality, pretty much anything where you're shoving pixels in front of your eyeballs, that's XR for this case. So the Google WebXR team is separate from the Chrome VR implementation team. We're more of a research and development group, and we're exploring what the future of the web looks like, specifically with AR and VR. And the future is going to be weird, for sure. But the past was also weird. So this is a Nintendo Virtual Boy from 1995, and it was one of the first stereoscopic platforms, meaning we have different images for each eye to create the illusion of depth. And it could only render in just red and black monochrome, that's it. And users had to push their face up against this device and have like a little Super Nintendo type controller to experience this. Unfortunately, this was discontinued 6 months after launch. But 20 years later, we've had many advances in computing. Only now is hardware capable of providing a truly immersive experience that we think of VR when we do today. Everything is new. This is a huge moment in time, and we have artists creating and companies experimenting, and we're all learning. And what started as mostly games and things, games-ish, we now have a lot of big players in this industry, and it's just been growing in the last couple of years. So, for example, for full room VR, so I think there was a Vive set up downstairs, meaning you strap on a headset, you have some controllers, you can walk around a space, and all that's tracked. So the HTC Vive and the Facebook Oculus are popular ones in those category. There's also a sitting VR. So you strap on a headset, and you sit down. You can stand up too, I guess. And you can just look around. You can't get up and walk around. It's just this orientation-based experience. And in that category, you have Google's Daydream and Samsung Gear VR. And you also have Microsoft researching mixed reality with the HoloLens. You have publishers like Steam, game engines like Unity and Unreal, all supporting VR. There's a lot going on. And most of these initially just targeted native platforms. But what about the web? So 3 years ago, Google and Mozilla got together and worked on a spec for WebVR. What is it? And it mostly just exposes VR hardware to the web. So now web devs can join in on all this VR hype. So that was a very, very brief history of VR. But before we get to the future, let's talk about the current state of things, because it's all cutting edge, and it's a little different than traditional web development. So where are we now with WebXR? We're going to check out WebVR. What is it? How does it work? And what's a VR browser? We saw a little bit of Samsung Internet for Gear VR earlier. And we're going to check out, explore a little bit what is possible with augmented reality in a browser right now. So let's start with WebVR. The WebVR API can be summarized by 4 major features. The first thing that we need to do is detect whether or not there's a VR device connected to the browser currently, or if the browser is running on a VR-capable mobile device. And if we are, we need to be able to query the device's capabilities. In a full-room VR situation, if we're connecting a website to that device, the website needs to know what is the bounding box and size of the room, because that's how you just run into TVs. Also things like the eye offset of the device or the field of view, because all these things need to be in sync with JavaScript land. We also need to poll the device's position and orientation. We need to know what the user's doing with their head and their body, how they're walking around their space. We need to translate that into JS land. And since performance is key, because otherwise people throw up, we need to hook into a request animation frame provided from the VR display. The Oculus and Vive both have frame rates of 90 frames a second. So if you think you're doing good with like 60 frames per second, nah, you got to keep going. So you have to hook into that. So here's a brief, non-complete example, just a high level of what this code could look like. And this uses Three.js, this blurb, which is a 3D library. It's like an object-oriented wrapper around WebGL. And from a high level, you have objects in 3D space with an X, Y, and Z position and a camera. And the camera is the user. It determines what is being rendered on the screen currently. So on line 3, we see navigator get VR displays. We're just querying the system to give us an array of any VR displays currently hooked up. And if we do find something like the Vive or the Oculus, on line 7, we can call request present. So, and we give it a canvas element. So 90 times a second, whatever we draw on the canvas gets pushed to the device. So that's how we determine what gets rendered while wearing something like this. And Three.js also has some components like VR effect, which gives us that stereoscopic effect, so 2 slightly different cameras, as well as VR controls, which translates frame data from the device into the camera. And that data is things like the orientation and position of the user. Because generally, when we're moving around in a VR world, we represent the camera. Quick example, but what if you don't have a high-end gaming rig? They require a pretty beefy gaming machine or a handful of the later mobile devices. Luckily, this is the web. So this is a video of showing some progressive enhancement concepts, moving between a mobile device to a tablet, to a laptop, to a desktop, to an Oculus. Web developers have been supporting multiple form factors and environments for years, so we got this. Phones, desktops, text-only terminals, refrigerators, not a problem. And there's also a library, the WebVR polyfill, that handles pretty much all of this for us. So for example, you make some 3D scene. If you're viewing it on a mobile device, we can use the orientation sensors provided from that device and just create a monoscopic experience. If you're viewing it on a desktop where we don't have orientation, we can use a keyboard and mouse. You also have the option of using a cardboard display. So you can render a stereoscopic image on your mobile device, so you get like a split screen view, and drop it into a cardboard device, which is literally just a $10 piece of cardboard and some lenses. And that gives you a rather immersive sitting VR experience. And if you are connected to something like the Vive or the Oculus or a Daydream phone, then it'll use that, and you'll get the full native experience. So we can develop and test on the desktop without like strapping this gear on, or even if we don't even have the gear. And this is huge for accessibility and truly one of the web's great strengths. So what if you're new to 3D development, you never use Three.js, or you're unfamiliar with WebGL? Not a problem. 2 years ago, I think, 3 years ago, Mozilla released a VR library called A-Frame. And it lets you write declarative HTML-esque code. And it's very extensible, and it has a powerful entity component system. It's a great open source community. They're friendly, inclusive, especially to newcomers. And they do open source the right way. So here's the demo A-frame scene. We have a box, a sphere, a cylinder, and a plane. So this is what the code looks like. We can see we have these custom new elements, a scene, a box, a sphere. And we define what this scene looks like with these elements, as well as HTML properties like position, rotation, color. And it's really expressive in a familiar sort of way, because this looks and is just HTML. So here we see we have an A box, a sphere, a plane, a cylinder. And this is what it looks like. So if you view this on a mobile device, you can look around with orientation, on a desktop with a mouse and keyboard, or if you have a VR setup, you can just strap right in and experience it. If you're interested more in A-frame, check out Liv Erickson's talk from last year's ColdFront. She's a great storyteller, and she has a great walkthrough on A-frame, so check that out. As a shout out for React enthusiasts, Facebook also has a React VR library, and there's also a React A-frame wrapper as well. So why the web? You can write once, and it runs everywhere. We saw some examples of VR content running on all sorts of form factors, and the web really excels at this kind of content responsiveness. And because of open standards, it's the same reason why your GeoCities from the 90s will still work today on Firefox and Chrome. And there's open publishing. There's no barrier, walled garden, or app stores in charge of your application. You're entirely in control of your application's distribution. And my favorite, linkability. Websites have canonical URLs, essentially like this address book of experiences. And we can also take advantage of progressive enhancement, enhancing the current web. Right now, the web is 2D content, or the flat web. And slowly, we can add piece by piece these VR or XR elements to existing content to take advantage when we're using a VR device or a VR-capable browser. And we'll explore more of that shortly. So that's a high-level look at WebVR. So what's a VR browser? How do those really work? So VR browsers are full immersion browsers. Right now, they're mostly represented by being dropped into this full environment, and you have a giant theater-esque screen in front of you. And we interact with it via a controller where we're clicking and dragging and scrolling and things of like that nature. Currently, out in the market right now, we have Chrome VR, Samsung Internet for Gear VR, Steam VR, the Oculus browser, and Janus VR. There's a whole bunch. And because most content is in 2D, I find it a little cumbersome to enjoy content in this way, unless it's like maybe like videos or full WebVR experiences. When you encounter a WebVR experience on a VR browser, you kind of just get like sucked into it. The exciting part about VR browsers to me is the way we can piece by piece enhance our content. So here's an example from the Samsung Gear VR browser. If you're on a VR browser, or specifically Gear VR, there's a function, Samsung Skybox. So if you do some feature detection, it's available when this code gets executed. Then if you're viewing some content in a Gear VR, you can control what skybox or models are appearing all around you. So you can start to imagine this more immersive experience where you're looking at an Airbnb page and the world around you is the apartment you're looking at. But if you're not on a VR browser, it's fine. It just looks like a normal website. And so this is how we start to explore the concept of progressive enhancement. So Voxel Kai on Twitter makes these cool videos of like navigating between different virtual worlds on Twitter, and they're just amazing. And so it kind of takes advantage of that concept of linkability. We have these canonical URLs. What if I'm in a WebVR experience, I want to click a link and go to another experience? How do we like work that transition out? So this is just like some concept. I think this is going to be a game. I'm not sure. But like teleporting between worlds, we're like approaching the metaverse concept. So last up on our tour of what we can do right now is augmented reality. Generally defined as layering content in front of the real world or on top of a camera. If you've played Pokemon Go, you know how AR works. So one of the first and most popular AR on the web experiences is AR.js. It uses get user media for video, and it's marker-based AR. So you do need to print or display a QR code-like marker. And with that, AR.js can calibrate where you are in relation to the marker. And we can render arbitrary 3D things with that. So the downside is you do need a marker, but the upside is it works anywhere get user media does. This is a fun one, CLM tracker. It's like a facial feature recognition. And so it's similar to like Snapchat-like distortion and overlays. This video is too much for me. And it's different than other AR stacks because it's more just kind of distorting and manipulating what's currently there and using computer vision to process that. So over the summer, Apple released iOS 11 with ARKit support. So it's their backend support for augmented reality SDK. And just last week, Google released AR Core, a similar concept for Android devices. So along with last week, we released some experimental AR browsers, one for iOS and one for Android, appropriately titled WebAR on ARKit and WebAR on AR Core. Great names. So in these browsers, they expose some features to websites, just like a bare minimum extension to the WebVR API to start exploring what AR on the web could be like. And as a disclaimer, this is not standards track. Like, we have to be very clear about that. But this is really for developers to start experimenting and exploring what could be possible in mainline browsers in a year or two. So there's 3 things we expose in these browsers. 6 DOF tracking, meaning 6 degrees of freedom. So we have X, Y, and Z of position, and X, Y, and Z of orientation. So this is similar to the full room VR experience that you would get from a Vive or the Oculus, but only using your phone's camera. We also need to expose a way to render the camera. We can't use get user media because the AR backend on mobile devices is using that. And we also need to expose camera intrinsics and properties because we need to sync our JS land camera to our physical device's camera, things like the width and height and the perspective. We also need to do some kind of surface detection. So we expose like a hit test function where you can cast out an array and see if it hits any surfaces. And these surfaces are detecting planes in the real world. So you can see in this video, we're just dropping cubes on the floor in a chair sometimes, I think. But so this is an example of this is where the users or the iPad is being tracked in all in position and orientation all over the room without any kind of room setups or anything like that. And we're able to determine the height of different planes, like putting a cube on the floor versus the chair. And this is just by processing each camera frame and looking for certain features and corners and things like that, and just slowly understanding the scene around us. So with just these 3 components, these 3 extensions to WebVR, we're able to create lots of different possibilities. And we're already seeing the community make some pretty cool stuff. Someone already made like an A-frame wrapper around this. So you can, if you know how A-frame works, you can start creating AR content with A-frame. So there's the A-frame demo just floating in space, and you can walk around it and everything. So here's an example of exploring what UX in an augmented reality world looks like. Apple just released a best practices document that just came out, but generally speaking, no one knows what's going on. We're all learning. So this is an example of like, how do you manipulate this object in space? And so it's a lot of poking cameras. But this is all new stuff. There are no rules. So along with these browsers, we also released a little library, Raps3.js. It abstracts away some of the differences between the two browsers, so you don't have to deal with any 3D math, and it smooths out some platform differences. So I wanted to show a demo of this, but you need just the right amount of light, and it works best on unique floors and surfaces. So outside, there's like a checkered tile, which will be great, and I'll show you all that after this talk, if you want to see it in action. But we can see here, we can walk around a space and select some points on a ground. And what this application does is it measures like, okay, well, you have a 50 by 65 centimeter area, rectangle, and it lets you know what furniture fits there, and you load it up and see what it looks like, spin it around. What does this chair look like in my living room? So that's the current state of virtual reality, augmented reality, and browsers designed for VR content. And like I said, this is a historic moment for the future of computing. Everything is new. It's exciting and a little terrifying. Like, we don't want to accidentally make an episode of Black Mirror. And we're exploring uncharted territories, like I said. There's no killer VR app yet. There's no, we don't have a complete set of UX patterns for any of this. Our best practices so far are still being discovered. And we don't know yet what success or failure even looks like. Everything is changing so quickly, and it's also new. So it's this new level playing field where it's up to web developers to determine the shape and the future of WebXR. Now, that being said, the Google WebXR team, we have some ideas about what the future could look like and where we're heading and why we think that's the case. So, thought experiment. What does the web look like in 10 years, the immersive web? So we can start to imagine the evolution of XR and how we consume content and how these different technologies begin to converge. Imagine walking down the street with non-obnoxious, rather stylish eye gear and, not like a giant headset. And we can see independent web content positioned in the real world. So literally like styled divs on surfaces on the side of buildings. So why do we think that's the case, right? So ideally, it's not a corporate-controlled dystopia, but we have interactable content that enhances your everyday experience, or maybe just sometimes. We can have embedded information at historical sites or museums, or context-aware information, like, yo, you have a flight in 2 hours, get out. Or overlaid route when you're trying to go to a restaurant, and at that restaurant it has a menu, and it has a wait, and that's all controlled via web content that only you can see with augmented reality glasses. So why do we think that's where we're heading? So when we think about the future of VR and what that gives us, it's kind of like this prereq for anything in immersive computing. We need solid performance and a way of converting our head and body movements and gestures into code, or JS land in our case. So 5 to 10 years from now, this baseline will only improve. When we think about the future of AR and what that provides us, it gives us scene understanding. We need to understand what the world around us is in 3D space. And it also gives us that 6 DOF tracking. So We need to know where we are, where the users are in 3D space, and then we can begin to meld those two worlds. But I think the real power of the future of immersive computing lies in these VR browsers. So we saw the Samsung browser start to expose that custom skybox option. So like this could be like a custom skybox of your Airbnb you're checking out. So when you're viewing this content, we can change the world around you. So you're in a headset in this case, a VR browser. You can also imagine other ways of progressively enhancing traditional 2D web content, like transparent backgrounds or embedding 3D content in a Wikipedia page. We can also imagine a new type of positioning system, possibly implemented with Houdini, of rendering things in 3D spaces rather than just X and Y positions. And as we continue down this path of progressive enhancement, we can rely on browsers being able to interpret this content semantically, which is something we can't do with just WebGL. That's just like a black box of rendering. The browser doesn't really know what's inside of it. And that's important because the web can be a dangerous place. And especially so in an immersive environment where it's very personal, it's very intimate. You're enclosed and you're unaware of the world around you in a VR scenario. So we'll need to explore what a user agent does in an immersive web. And the user agent is this concept in current browsers. It's just like a series of features that's designed to protect the user. Like, whoa, this SSL certificate, not safe. Are you sure you want to go here? Or I have your password saved to this website. Here you go. Or are you sure you want this site to access your webcam? So the user agent in an immersive environment should be no different. And we have an even higher obligation to protect our users. For example, by not allowing content to render in your personal space, because in a VR world, that's very intimidating. It's very stressful. No one likes it. So we can imagine these avatar representations of a user agent in a VR world, even if we wanted to. And these user agents can also provide prompts and utilities and give you objects representing things like your credit card information or password tokens and things like that. So there's a bunch of crazy ideas here. So as progressive enhancement improves in VR browsers, and we approach a world where rendering DOM content in an augmented experience, thanks to 3D positioning, we've learned in VR browsers, we can provide safety for our users with the immersive user agent as well. And that's important in this immersive world because if you're walking across the street, you don't want an ad rendering in your face, right? So the only thing missing here with all these different ingredients is some concept of anchoring a website with a physical location. But that's only a matter of time before we start to imagine these different data sets, different or ubiquitous or competing data sets, mapping geo-coordinates to URLs. So that's a little bit about where we think we'll be in 5 to 10 years, and a little bit on how we'll get there. With advancements in browsing, VR, and AR, we're going to need to rethink most user interactions, and also how content is even consumed on the web. And it's up to web developers, all y'all, to begin building that future and discovering what's next, what's new, what can we build, what's going to be the new standards. And so it's a very empowering moment for web devs. We're able to start defining these new futures and make sure it's a safe environment, make sure it's a fun environment. This VR and AR concept has this inherent sense of funness to it. And so we can start developing these new interaction models that we kind of take for granted on desktop, things like scrolling, clicking. What is that in an AR world? How can I interact with something that only I can see through some lens? So I hope you all check out what's going on in XR and follow along. And as this tech progresses, explore what's possible and what could be. Thanks.